Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. I hope you've all had a great weekend. Yeah, mine was pretty good. We went to a theme park for like the first time in a year or two. So yeah, that was pretty fun. But yeah, that's why the stream is on Tuesday this week instead of Monday, because my voice was completely shot. I forgot like how loud it is there and trying to talk over everything. But anyway, so let's go ahead and get started. I'm gonna work more on tessellation shaders this stream. Yeah, so last time we were trying to make a wireframe shader, and that's just kind of to be able to test out how the tessellation works. And I tried a few different methods. This one uses shader partial derivatives, and it looks pretty good. It's like in screen space, so no matter how much you zoom out, the thickness of the lines is the same. So that's kind of nice. I had another, let's see if I can get it. Can't remember what state I left it in. All right, let's go ahead and emit. Okay, what branch am I in? Okay, I'm on the master branch. Say, finish up partial derivative base wireframe. So I had another method where I tried to like build like the actual wires using a geometry shader, and it was having some weird bugs last stream, but I managed to fix it. Okay, so it's yeah, and I was doing some different tests to see if I could get it to work in screen space, but I didn't like it quite as much. It's nice because you can see the back, but then there's some kind of, well, what I was mostly trying to fix is on the sides you can, the wires, I guess they have perspective, so you can see that they're flat there. So I was going to see if I could get them to always face the screen in an easy way. But then I started thinking, well, that's basically just what the partial derivative version does, so why even bother? So that's kind of why I switched back to using the partial derivatives. But anyway, the problem last time was that I was basically calculating this in center, which we didn't really even need to do. You can just use a vector from the point to like the halfway point between the other two corners of the triangle, instead of trying to calculate the quote in center of the triangle. Oh, I just realized my mic is kind of far from my voice. Is sorry if it's been quiet. Let me fix that. Okay, hopefully that's a little better. All right, so anyway, let's switch back. Yeah, I was starting to like, we don't need to work too much on the wireframe because it's basically just a debugging tool. So I don't know, maybe someday I can try to perfect these different systems. But yeah, this works fine. Okay, so now I want to add tessellation to this, and what tessellation does is basically it subdivides all triangles in the mesh into multiple different triangles. And the cool thing about that is that you can calculate the position of each vertex that's generated, so you can use it to add like height maps, add more detail to the mesh. There, you can use it to calculate lighting. So like if you have a really expensive lighting algorithm, you can calculate the lighting at each point and then kind of interpolate it between the different pixels or fragments, so you don't have to do it per fragment. There's a bunch of different uses for it. So I'm gonna, yeah, my next tutorial is gonna be mostly about tessellation shaders. Okay, so there's two parts to a tessellation shader, something called the hull function and then something called the domain function. And the hull function, you basically take two triangles of the original mesh, or not two triangles, you take one triangle, so 3 vertices, and then you tell the system how many times to subdivide it. And then the domain function is called once per vertex in the tessellated mesh. And it also tells you like what triangle it was originally part of and the barycentric coordinates for that triangle. Or, yeah, for that vertex in the triangle. Okay, so I have this grass shader from my grass system. Has a geometry, has a tessellation shader already set up. So I'm gonna just be referring to this probably. So the first thing we need to do is register our 2 new functions here, just like all the other shader functions. So we have the hull and the domain function. And now we need to actually write them. So let's see here. Okay, so I'm going to basically be able to use this hull function. Okay, and if you're wondering, yeah, the hull function is called after the vertex function. Okay, and we're going to need, yeah, this tessellation control point. Basically what I'm going to call the path structure between the vertex and the 2 different tessellation shaders or tessellation stages. So we'll have the position OS, and then you can't just use this position semantic. You have to use a special one. I think it's called like, yeah, internal test pose. Okay, and so then the hull function, or the domain function rather, will export this geometry input structure, which will be sent into our geometry function. Okay, but anyway, let's take a look at, I guess first, let's update the vertex function. Okay, and then the hull function has a bunch of different, like, metadata tags. So the domain basically tells it what type of primitive you're working with in your shader. So in Unity, we almost always use triangles. So I think we'll probably just be using this in the tutorial as well. But technically, you can work on lines or even quads here. And then this tells you how many points you're going to output, which depends basically on the domain. Okay, and then this output topology, we want it to output clockwise triangles. There's also counterclockwise. I'm not sure what other options there are. Let's see. Okay, so yeah, you can also output points or lines. But yeah, we won't. Well, I might look into that, but in Unity, you almost always use triangles. So Okay, and then this partitioning is kind of interesting. This, we'll look at this later, but you can set different ways for it to partition the mesh. I think yeah, right now we'll just stick with integer. And then this patch constant function is called, oh, let me see here. Yeah, it's kind of like an extra function that's part of the whole, but I think it's called, I'm trying to remember at what point. Okay, so input patch, isolation factors. Yeah, well, the main thing is it kind of just, it tells the shader how many or how much to tessellate this triangle. So like if we just put 1 in for each of these, it would not tessellate it at all. So when you put in higher numbers, it starts to tessellate the triangle. And you can tessellate the edges at a different amount than the inside. And the reason that's good is because you need the edges of neighboring triangles should be the same. Otherwise, you'll get weird like holes in the mesh because the vertices won't match up. But I'm just trying to remember the order when this is passed. Well, maybe we can play with it more. But I usually, yeah, the whole function is usually pretty simple. I guess it, okay, let's see. Maybe yeah, there's a cat-like coding. Can't remember the exact order. Okay. Yeah, but this cat-like coding tessellation, if you want a little bit more in depth about it. Yeah, so the patch, how the patch is to be subdivided is a property of the patch. This means that the patch constant function is only invoked once per patch and not per control point. Okay, so that's, I see now. So yeah, basically this is called once, I think, before the whole shader, and then the whole function it's called once per control point. So this is when you'd want to do, yeah, if you wanted to do specific logic per control point on the patch, like I don't know, if you wanted to, basically if you wanted to export another type of structure that had additional information, you could do that. And then the domain function would have that information. Maybe I'll try to find a good use of that, but usually I don't really do anything in the whole function because usually whatever we could do here, I just have already done in the vertex stage. So I guess the reason that you might, okay, well at this point you actually know like all the points in a triangle, so you could do something with that. So yeah, I guess that's kind of interesting. Okay, but anyway, so what I want to do here, this position, tangent space, and tessellation factor is from my grass shader, so we're not actually going to need that. I'm just going to have tessellation factor value, and we'll just keep it constant for now. We'll play around with more interesting things later. Okay, so that's fine. So this is all the patch function, or the whole function. And then the domain function is kind of the interesting part. I guess I don't need all this stuff. And so this is where the shader has already tessellated our triangle. So it subdivided it into a bunch of different points. And at And so now it gives us information about each of the points that it's generated. So first it gives us the tessellation factors for the patch or the triangle. And then it gives us the tessellation control points for basically the whole triangle. And then it gives us the barycentric coordinates for the point that is generated. Note that we have to use this domain location semantic. And barycentric coordinates, you can kind of see here, it's kind of like a weight towards each of the corners of a triangle. And if you add them up, they should equal 1. So if you wanted to find the position of the point in world space based on the barycentric coordinates, you could just multiply the world space position of each triangle corner with its barycentric coordinate, and that would give you the world position of the tessellation point. So this little macro just lets us easily average using the barycentric coordinates. Okay, but so our domain function needs to export geometry input. Okay, and basically all this has is the position object space, so we can just also do this equals barycentric interpolate. Okay, so this macro will then read the position object space out of each patch's tessellation control point structure, or each point's tessellation control point structure, and then average it. And we can return output. Okay. And I think... Okay. Program uses tessellation shaders, treating if program require tessellation. Okay, so maybe I just noticed that everything is empty, or the scene is empty. Okay. Probably should just update this pragma target. Yeah, because we're using 4.5, so we can just do 5.0 and... Okay. But we still, obviously, there's some problem because we don't see anything. Let's see. Let's look. At the frame debugger and see if it will give us a little bit more information about what's going on. Plugin event. Not sure what that's doing. Okay, so it's drawing our meshes, but oh, I know why. It's because the tessellation factor is probably set to 0. Yeah, because I didn't set up the property here. Okay, so I guess if it's 0, that means it just won't draw. So that's good to know. Let's set it to 1 by default. Okay, yeah, there we go. So when it's set to 1, that means we just get the mesh how it is with no tessellation. And when it's set to 0, then it just disappears. So when we set it to 2, it should tessellate. Okay, and it does. So you can see it's subdivided each triangle into a bunch of other triangles. Can switch between them. And so pretty much you can tell it finds the center point of the triangle and then just uses that to create 6 other triangles. And then if you go up to tessellation factor 2, then it creates more triangles. Although this time you can tell it's a little different because here it deletes this vertex and it's like created this different pattern. So it's not quite like it just keeps subdividing each triangle. It's a little bit more complicated. But you can see that this original edge always stays there. Okay. Yeah, so yeah, I'm glad that the wireframe shader is working well. Okay, so let's change this partitioning value. This will change the way that the tessellation shader I guess subdivides triangles. Okay, and so the integer is what we've done here, but the fractional even and fractional odd actually are, I guess, continuous because they can take any float value. So I guess nothing below 1, but as we increase it. Okay, so you've got to go at least to 2, and then you can see it kind of smoothly interpolates. So as you can kind of, I guess the tessellation values won't jump, which is kind of nice. So it's good for level of detail because you won't be able to notice it like snapping to a higher level of detail. It will smoothly transition. So this is tessellation. What did I do? Okay, so that's even. So let's look at odd. Okay, so yeah, odd seems to come from the outside. Well, even comes from the inside, basically. So there's just slight variations. You can see what looks better. I wish that there was a way you could choose this per material, but I don't think there's a way to do that. Let's see. Tessellation, partitioning value per material. They both look super cool. Yeah, I think they do look pretty cool. Yeah, it's fun to watch it. I'm glad the wireframe shader turned out really well. And by the way, hey Finzo, thanks for coming by. Kind of funny. You only have to go to tessellation factor on the sphere. Wait. Oh, I see. So the odd. Oh, right. Okay. So you can notice on the odd tessellation, when you go to 2, it's not at like a full tessellation value. So that's why they call it odd. Yeah, I forgot about this. Because at every odd number, it basically reaches a complete, I guess, doubling of all vertices. So we can see 4 is kind of, again, halfway. Or I guess it's the opposite for even. Yeah, so 5 here is like halfway. Okay, and then there's one other method. Oh yeah, I'm kind of getting sidetracked. I don't think that there's, unfortunately, a way that I can specify the tessellation partitioning value per material, like with a drop down. At least I've never seen that done before. Kind of like how you can do it, how you can do culling values with an enumeration, where you can, I don't know, you would do something like, and then set up the cull property. I'll have to... I might just not be using the right Google keywords here. Let's see. Tessellation, shader, change partitioning with keyword. Oh, I guess we could do that. Okay. Yeah, because we can do like an if else, maybe. Let's try it. Okay, let's look up. Trying to find the syntax for this. So, okay, we'll have keyword enumeration for the tessellation factor. So we'll do integer fractional even. Okay, and then, yeah, we haven't even tested out the other one, but I think the other one is yeah, power of 2. Okay, so okay, and then we need to do a shader feature for this so that Unity knows to compile a version with each of these keywords. Okay, I guess I'll have to fix. Okay, so yeah, it's partitioning, integer. Okay, so now we've told Unity to generate a version of the shader with each of these keywords enabled. And then we've also placed in a property that you'll be able to choose between them based on the material. Okay, and yeah, we can see it here, although it doesn't do anything yet, obviously. So then in the shader, we would do something like this. And I think this will work. I've never actually tried it. There might be something like you can't use, I don't know, these things. And thanks for the follow. These preprocessor directives for, I don't know, function metadata tags. I'm not sure. Is that right? I spelled it. Oh yeah, I didn't even spell it fraction, but okay. How do you spell integer? Okay, so then we have fractional odd, and then that power of 2 version that we need to test out. Okay, I guess the only problem is this does make it kind of confusing to read. But okay, so it's not complaining, so that's good. If we set attribute expected where partitioning mode is one of integer. Oh, okay, I think I probably just spelled it wrong. Fractional even. Okay, that doesn't seem like I made any typos. Okay, maybe... Oh, what did I do? Oh, okay. I don't have the T in there. Oh yeah, and this doesn't have frac either. Okay. So gotta watch out for those typos. Okay, yeah, so it is working. So that's interesting. Integer is the same at 4 as fractional even. Okay, let's look at this POW2. I don't know. It seems the same as the integer. I have to admit, I haven't used that version before. I usually stick to integer and the fractionals, so... Let's see, maybe some more information about the power of 2. Okay, well, according to Apple, partitioning mode, the result is rounded up to the nearest integer, n, where n is a power of 2. Okay, but that doesn't seem to actually be happening. Okay, well, I guess 2 is a power of 2, so technically we would think... So integer, it's 3 here, but we would think that power of 2 would be rounded up to 4, but it's not. So I don't know what's up with that. I mean, maybe it just doesn't work on my platform, or I'll have to do a little bit more research. But anyway, so now we've got... We can easily switch between partitioning pretty easily. So that's nice. Okay, so we've got a simple tessellation shader set up, and the wireframe is looking good. So I think actually this shader is pretty much done. Maybe, let's see. Maybe we can make this a little nicer by letting me set, okay, so this is kind of interesting. I just noticed. So fractional even if you set it to 1, it still tessellates. So you can't get less than 1 tessellation with fractional even. I guess because it always rounds up to an even integer, which would be 2 at this point. Okay. Sorry, I got sidetracked there. Oh yeah, I want to make maybe the wireframe look a little better. Let's add let's see, just a background color. Okay, I guess we'll spell it out. And then I was also thinking maybe we would shade the wires. Okay, so it doesn't do anything yet. I need to interpolate between... Instead of just multiplying the wireframe color by min-barycentric, which makes it go to black, I need to do lerp background color, wireframe color, and then use min-barycentric as the interpolation value. Okay, so now if I... Yeah, there we go. Just want to make sure. Okay, it was set to linear space. Okay. So you can add lighting pretty easily. We might as well just use Unity's built-in stuff. Okay, I guess the interesting part there is going to be trying to find the correct functions or correct structures to send. Okay, so yeah, I know there's going to be the this input data. And then the lighting data. Huh, this looks different. Okay, yeah, the surface data was what I was trying to look for. So I'm not sure where that's defined. Okay, well here's the input data, so that's good. It's an input.hlsl. So I might as well get this done first. Okay, so I'll just put this here so I can remember. So input data. Okay, so we don't have a world space position in this function, but we can get it relatively easily. I'll just assume that we have it, and then input data dot world space, same type thing. Actually, now that I think about it, do I want to do this in the shader? Because it is going to kind of complicate things quite a bit. And maybe it's nice just to have this simple shader to just illustrate how tessellation works. And maybe we'll have a different one that has tessellation on an actual, like, textured object. Let's see here. Okay, so we got that done. Okay, so we did the different partitionings. Okay, so this is kind of interesting, but maybe we'll do that in a second. Okay, let's just make, I guess we'll just illustrate, I just realized the lighting overexposed a bit. Okay, let's just do a simple lit shader with tessellation. Okay, so yeah, I think I'll have that in a separate shader. So let's close this for now. We'll just keep this simple wireframe. Okay, so I think I'll get started by duplicating the shader file. And we'll call this Tessellated Lit Shader. And we're gonna pretty much try to recreate the Unity Lit shader in this, but I mean, it's kind of complicated, so we'll see how deep I want to go into it. All right, so we're not gonna have any of this wireframe stuff. Let's see, it might be quicker. was gonna say I could use my foliage shader kind of as a base. Okay, so we'll have the main texture and then a tint. Yeah, I guess we can do alpha cutout. And we'll have a normal map, smoothness. Do I want to have a data texture for this type of thing? Probably that would be better. Okay, so smoothness, AO map. I don't know what else we'll need. I guess technically we could have like a tessellation factor map. I don't know if that would be useful. Okay, we'll keep. I guess we'll keep these. This will actually be ambient occlusion minimum. Okay. So I think this will be kind of a base for a good lit shader. I mean, the Unity lit shader is way more complicated because it has like a bunch of different options and you can turn on and off keywords depending on what you set. But I'm not really going to try to recreate it entirely. Because let me think. I mean, really, just being able to tessellate this is not really very useful. You want to combine this with one of the other techniques. But I guess I just want to have this as a base. And then we'll add, so like I had on my outline, you can tessellate silhouettes, which, I don't know, if you look at a low poly model, one of the things is even if you have really smooth lighting and normals and everything, the silhouette of the mesh will always still be kind of jagged. But with tessellation, you can actually improve that. So I think that's kind of what we'd want to add to this shader. Which I guess we'll do. I don't think we need to have that here. And yeah, we don't need a geometry function anymore. Okay. Okay, so this is tessellated, lit, included. Okay. Let's see. So here we're gonna have position. We'll have the normal, so object space. We'll have the tangent. And we'll have UV and light map UV. I think. Oh yeah, and then there's other stuff like this isn't the version I want. Okay, yeah, this is the complete version of my foliage shader. Well, it's not technically complete. I'm still working on it, but okay, what I wanted to see. Oh yeah, so I need this macro for instancing. I don't know if instancing works with tessellation. Maybe, okay, I'll just add it for now. We can always remove it. Okay. Basically, this is going to be kind of the same. Okay, so interpolators. Yeah, I'm not going to worry about all this pass stuff yet because we'll just do the lit pass. Okay, so UV, normal, position, tangent, light map, fog factor, eclipse base position. Okay, so the tessellation control point. I guess it depends when I want. Well, I guess when we tessellate, we kind of want. So basically, I think in our tessellation, we'll just use the same values that we do here. But we can't use the same structure because we have to change this to that. Oh, what was it? I guess I shouldn't have deleted it. This internal test position, which is sort of annoying, but I think we can actually use all the other same semantics. Okay, and then yeah, we're not going to have any geometry functions. I guess this tessellation, it should technically go up with the other control factor, shouldn't it? Control structures, I meant to say. Okay, so here, again, I copy and paste some information so I don't have to do it separately. Or I don't have to type it all out again. Okay, and I guess we might as well use the C buffer. This also helps with instancing. Don't need that stuff. No subsurface. Okay, spelled this out. I could do it like that, actually. Okay. What did I name the data texture, actually? Oh, I didn't name it. All right. Okay, so the vertex takes in the input and it outputs this tessellation control point, and I think it basically is going to pass all this data through. And I don't think you can't just leave out the vertex function. You always have to write it, I'm pretty sure. But I'm trying to think. I don't think there's really anything that we can do here that will save us any time that we couldn't do in the tessellation. I guess we could actually scale the UV, so let's just do that. Transform heck. And then the light map. I guess we could also scale the light map UV. What is the macro for that? Okay, I think I kind of have to do these at the same time, but I kind of want to do... Let me look. Okay, so I want to look at that output SH. Okay, so if the light map is on, okay, output SH does absolutely nothing. And same with this. So if the light map is off, output UV does nothing. Okay, so I think it will be safe to scale the light map UV in the vertex function, but then output spherical harmonics in the domain function, which I kind of want to do because that will give us more, I guess, what's the right term? Like finer grained light probes. Which I guess is kind of the purpose of this shader. I mean, you could do it either way. So... okay. One problem is that assumes that there is a light map. I guess there always is a light map UV, so that's probably okay. Yeah, I guess technically if light map was off, this is slightly inefficient because we don't really have to do that code if there's no light map. And then we could even not even include this interpolator. Oh, I guess it's not really an interpolator here, it's just passing stuff through. Okay. Well, let's just not worry about it right now. I'm probably really overthinking it. Anyway. Okay, so I think... Oh yeah, I need to do the instance. Okay, so this I don't do here, but I do need to transfer instance ID. Oh, one moment, I'm getting a call. Oh, well, it just hung up. Okay, I'll check that later. What was I doing? Oh, right. I'm trying to set up the instancing. Okay, so this setup ID. I need to look into this more. I might not need to call it in the vertex function because I'm not... Well, no, I guess I am using the scaling. Okay. So the setup ID sets up all these variables to use what's in the instance buffer. And then transfer ID just transfers it to the output structure. So I guess, yeah, I was going to say, I guess I don't need to set up the instance ID because I don't use any of these values, but I actually do here in transform text. So Okay, so I think this is good. Okay, the patch constant, we'll still just use this tessellation factor. Yeah, we don't need all this. I'm just going to use fractional odd. I think it usually it kind of looks the best for this type of thing. Let me check. Did they? Okay, so on the domain function. Okay, so the whole function again will just pass through the patch. Again, you can kind of do stuff here if you need all the triangle points, which I guess if you did it here, it'd be slightly faster than doing it in the domain function. So I guess, yeah, if you, because a lot of times you'd use a geometry function to set, actually, oh no, this wouldn't work. I was going to say, couldn't we use the hull function to set this barycentric information? And then I wouldn't have to use a geometry function. But the problem is that we need this to run after tessellation, which the whole function runs before. So yeah, we can't do that. But if you wanted to do like a flat shading shader where, you know, like I guess where you recalculate the normals to be flat on the face instead of like averaged, then you could do it here because you need triangle information for that. Actually, did I? Yeah, I had this here. So maybe I will try that out because like when you deform meshes, kind of like we did with wind and the foliage shader, you need to be able to recalculate the normal vector, and you need well, the easiest way to do that is if you know the position of all points in the triangle. So technically you could kind of use the hull function for that. Might be sort of overkill because we wouldn't actually tessellate, but that is one way to do it. Anyway, I'm kind of going on a tangent again. All right, so here on the domain function is where we need to do all the stuff we'd normally do in the vertex function. Okay, so let's see. First, we need to convert the object space position to world space. So we'll take the position object space. Okay, and then we can set output dot position world space. We also will have the clip space position. Okay, then we can do something similar for the normal. Yeah, and these this function is built into URP. It's actually in the it's kind of complicated. Or not complicated, it's kind of confusing. I think it's in the input HLSL. No, it's not. Oh, shader variables functions. Yeah, this has these functions if you're curious what's inside them. Okay. So actually I need to grab the tangent differently. So this will be the this is kind of interesting. I guess yeah, because I need the bitangent flip or multiplier. And that's usually the fourth component of the tangent vector. But I wonder, I'm going to assume that it's the same for each point in a triangle, because it wouldn't make much sense otherwise, because your pi tangent, excuse me, would be flipping between vertices, so that doesn't make any sense. So anyway, I'm going to grab that there, and then we'll interpolate between, I guess this is actually normal OS, and then very centric. Interpolate XYZ. Okay, and then from that we can output. Oh wait, I guess this will need the flip vector, won't it? So I guess we can look and see. Oh, I see. So you just actually pass this into here. Okay. Well, I still need it separately, so I guess we could do this. If I can actually type. Okay. Okay, so this has the normal world space and also a tangent vector and world space, but it's only a float 3. So we need to just add back in the flip because we'll need that in the fragment function. Okay, so that's that. Okay, UV, excuse me. We can just pass through because we already scaled it. So we can just call very centric, interpolate UV. Okay, and I guess, so here, let's see, maybe we do need to do a bit of defines here based on the light map. So if def light map on, because yeah, if there's no light map, yeah, first of all, we don't have to send this through here, so we save a little bit of work. But then also, yeah, we actually will, I don't think we can just use those macros for this, because we need to know whether we've already scaled the light map UV or not. So light map on. Okay, so if the light map is on, then we can just output the light map UV, and we've already scaled it. But we've got, again, to interpolate. Okay, and then, oh yeah, this is if def. So otherwise, we need to deal with Spherical Harmonics, which are light probes. Okay, so this is the normal vector, which we can just grab from here. Okay. And then, yeah, once again, I need these two functions. Okay, and so it's not outputting a geometry input either. It's outputting an interpolator structure. Okay, so we've got position, normal, tangent, UV, light map, UV. Oh, I'm looking at the wrong thing. UV, normal, position. It's kind of. Oh, okay. I think the reason it's like this, yeah, is because of passes later. But I was gonna say it's kind of organized weird. And then light map. Okay, so we gotta do fog factor. And I guess the stereo output. That's for VR. Can't really test it, so maybe I shouldn't include it, but fine. I wonder if I need to do this in the vertex function. Okay, fog factor. Okay, so we can get the fog factor from the clip space position and then vertex lighting from the world space position and normal. And then we just store them in this variable. Okay. And I think that's all. So now in the fragment function, we just need to compute the lighting. Okay, so let's get rid of all that. And yeah, all this that was from the geography function. Or not geography, geometry. Okay, so I can use some of this stuff from before. Don't really have to do this as front face thing. We're not going to worry about double-sided rendering. But I'll go ahead and copy all of this. Okay, let's clean this up. Oh yeah, we're not going to do that. I mean, I guess, no, I'm going to keep it simple. So we're not going to have any other pass logic in here for now. Okay, so we've got tangent to world, normal, blah, blah. Don't need this. Okay, so I changed this to data map. Okay, so, oh yeah, no flipping. Okay, let's just test if it works, I guess. So let's set color to the main sample and then just return color. Okay, normal map already exists. Oh, yeah, tessellated lit. Shader needs to actually use this the correct. Included file. Get vertex position inputs. Okay, so basically this error says, yeah, I don't know why it's phrased this way, but when it says no matching zero parameter function, that basically means that it doesn't recognize the variable that you're trying to pass to it. So either this or you can't use, either I made a typo here, or you can't use the macro as an argument, which is kind of annoying. I forgot the position object space right there. Now that I think about it, it's probably, yeah, it'd be better if we converted from object space to world space in the vertex function, because then we'd have to do less matrix multiplications. Okay, so let's go ahead and do that now because that'll actually simplify things a little bit. Okay. So take this. Okay, so that means the tessellation control points will actually have all world space vectors. Okay, so world space, world space, world space. Technically, we could also export the position, but I think I'll wait to do that because we might modify the position based on the silhouette like I was talking about before. So if that's the case, we'd have to recalculate the clip space position anyway. So yeah, let's not do that. Okay, and yeah, we don't have to interpolate in the vertex function. And yeah, we can just pass the entire tangent vector. Okay. So that's better. Yeah, so now I don't need this stuff. So the position we'll just call barycentric. Interpolate. Okay. And okay, so now I need to calculate clip space from that. There, instead of calling this function, there's a quicker one. Or not really quicker, but just for calculating clip space position. Where is it? Oh yeah, it's in the core shader library instead of the URP. Yeah, here it is. Transform world to clip space. Oh, hi, i3. How you doing today? Oh, yeah, this is supposed to say position world space there. And again, we can interpolate that. Okay, so normal world space, tangent world space, and then just, yeah, again, just the XYZ components, if I can type it. And then this, we'll just take the patch 0, tangent world space, WVAC component. Okay, so I think I fixed that up. Normal position inputs. Oh, okay. I know why it's complaining, because no, I was gonna say I didn't include the lighting, but I actually did. Oh, yeah, it's not normal position, it's vertex normal inputs. Oh, I did the same thing here. So it's get vertex normal inputs. Okay, oh, doesn't like the semicolon, so I think I'll get rid of that. That's probably what the other error came from as well. Oh, okay, so this is different. You can just change this to input dot normal world space. What? Oh. Okay, so we'll just do float. That's fine. Domain, not all control paths return a value. Did I? Okay, I just forgot to do this. Return output. What's the difference between a geometry and a compute shader? Well, a compute shader is basically just a program that you run on the GPU, and it can do pretty much anything. Where a geometry shader is a stage in a graphic shader that you can modify or add triangles to your mesh. So a compute shader doesn't necessarily have to do anything with drawing, whereas a geometry shader is meant to modify a mesh. Okay, so let's do tessellated lit test. Okay, I don't have any textures ready to go, so I think I'll steal some from my foliage shader tutorials. Do we already have it? This is a different. Okay, I don't know if I'll need all this stuff, but we good to have around, I guess. Okay, let's set everything up. It's not this RGB. Don't need bitmaps. And turn off compression. This is a normal vector, or normal map, I mean. And then this is not sRGB. Okay, and then here, you can use the neutral gray. Set it there. We won't have any alpha clipping on this one anyway, but none of this is really effective right now. Okay, so if I set it here. Okay, so yeah, we see a color. Nothing happens, but I can tessellating a bunch. Okay, actually I was wondering, like, does Unity's wireframe view actually show tessellation? So that's good to know. Hopefully it works for Mac developers since they can't use the wireframe shader because geometry functions aren't supported on Mac. But so I hope that this works for them so they can at least use this view to test what's actually happening. I don't have a Mac to test that out myself, but anyway. Okay, so yeah, everything's working right now. We don't actually see anything. Let's okay, add some lighting. So we have this input data. So I'm gonna just use Unity's normal QBR lighting algorithm. So we'll try to get that all set up here. I think I'm gonna call it lighting input. Oops, what's going on? There we go. So we have the position world space already. And then we have the normal, because we just calculated it with the normal map. The view direction we can get with a simple little function. I think it's in here. Yeah, get view direction from position. So basically, this just, oops. This looks at the camera position and then subtracts the world space position of this fragment. Input. All right, and then we've got the shadow chord, which again I should have. I have this little function. Now, actually, I need to test this, but actually, while I'm here, I'm just going to download all the, or copy all these functions because I'll need them for the Shadowcaster. But Unity added new screen space shadows. Actually, it just came out this morning, 2021.2. So I'll need to look into that. I need to update my shader graph because now you can finally use screen space ambient occlusion in the shader graph as well. And we have custom vertex interpolators, which is pretty nice. Get shadow coordinate is what I'm looking for. So yeah, I don't know if this still works actually in 2021.2 because this get shadow coordinate. Yeah, because they changed the way screen space shadows work. But well, maybe that would be a fun stream is where we go and check out all the changes. I need to find their changelog has a ton of stuff on it, and I don't know if it has all the URP changes, so I need to go and look. Okay, but anyway. Okay, so the fog chord is just input fog chord, or it's vertex lighting and fog chord. Okay, actually it's the fog factor. I wonder if it's different. Don't think so. Guess we can look in the lit shader and see. Okay, here. That does not have what I need. So forward pass maybe. Let's see. Okay, yeah, so they just pass it through. I wasn't sure if the fog chord was different than the fog factor. Looks like it's not. Okay, so now I have vertex lighting, and this is just YZW. The baked global illumination. I think we can just, yeah, use sample GI and pass that information. I guess I can just copy this. Save myself some typing. Okay, so yeah, we either use the light map UV or the spherical harmonics. That's actually a good idea. I should probably use this. Okay, and then screen space. Normalized screen space UV is for screen space ambient occlusion. And this function is included in URP somewhere. Maybe space transforms. Usually they put kind of stuff in there, but I think actually screen space is in some other file. I'm not sure where that is. That's one confusing thing about the render pipelines is it's hard to figure out where our functions are stored in the, I guess the code, the source code. Okay, and then yeah, shadow mask is baked shadows, so that's all good. Okay, so we've got the lighting input. We also, there's this other thing called surface input, which includes, actually not sure if it's surface data or surface input, so I should look that up. But like the color and smoothness and stuff, and I don't know where that's stored, so let's go see if we can find it. Maybe it's in surface input? No. Surface data? Okay, that actually wasn't too difficult. I should probably, yeah, let's actually put a little thing here. So found in the surface data HLSL. So that way, yeah, in the future I'll be able to point people there easily. Yeah. This was in, was it just input? .HLSL? Yeah. Okay, so the surface data will need the albedo, which is just the arc. Basically, it's our main color. Sample RGB. Yeah, for some reason they asked for the alpha, which we got there. Gotta head to class, CNN. Good luck with your wizardry. Okay, thanks, Sleep Enzo. Appreciate you coming by, and I hope you have a good class. Okay. Oh, I guess we can do metallic. Maybe that should go in our data texture. I mean, why not? I don't really mess with metallic workflows very much because I tend to do more stylized stuff. But I mean, sure, it can go in here. Okay, so we'll do metallic times the data sample dot R, I guess. And then smoothness will be times the data sample green color. Okay, I don't know why it needs the tangent space normal, but I'll give it to it. We have it. No emissions. We could have an emission texture, but I don't know. So occlusion, I want to interpolate between the ambient occlusion minimum and 1 based on the data sample blue component. Okay, already did alpha, and yeah, we're not gonna have any clear coat stuff, so. Oh, hi NTT, how you doing? Okay, so we've got that set up. Okay, so this is all the data you need for the PBR lighting algorithm. So we can just pass that through here. Universal fragment PBR. Pretty simple. What is that? This. We pass it the lighting input and the surface data. And then it takes care of all the lights for us. Okay. So yeah, I mean, if we wanted to have a truly like equivalence to the lit shader, then we need to add an emission texture and then some kind of clear coat support, but I don't know, it's not super important to me at the moment. Okay, so let's change this. So this will be metallicity, smoothness, AO map. I guess let's keep the same order. Am I spelling that right? I don't know if it has 1 or 2 L's. First I thought 2 L's, but now I think it might just be 1. Oh, nope, it's 2. Okay. Alright, so let's see. Undeclared identifier main stamp key. Okay, so I did a typo, of course. Valid subscript alpha. Oh, that's because I just need to pass the A component. Data sample. Oh, right. Does it need that underscore? I don't know why I was doing that. Okay, so there we go. Do I plan on using this tessellation for another project? It's mostly just for our tutorial. Although we do use tessellation in the grass blades, which is pretty much what I'm working towards. Okay, so you can see the metallicity. It's kind of hard to tell because also the main texture is just gray, but I think I'll just turn it off. And then smoothness. Ambient. Okay, so yeah, this is what happens. If we set the ambient occlusion minimum to 1, then yeah, it's not, we don't see those stripes anymore because the ambient occlusion isn't happening. And then I can turn off the normal map. Okay, so everything looks good, I think. Okay, so we have tessellation here, but you can't tell. It doesn't actually do anything at the moment. I guess technically, if you had... Oh, you could tell if I set up some light probes because we test light probes on every point, tessellated point. Maybe we should do that real quick. Okay, let's set up. What am I looking for? Oh, plane. Okay, so let's just give the plane the same material as well. Oh yeah, and there's no shadows right now because I don't have a Shadowcaster pass, but we'll add that soon. Yeah, just center it and set this to static. Let's add some lights. I guess let's clean this up a little bit. Call this ground. This would be nuts with a water wave shader. Yeah, that would be cool. I really want to do water at some point, but well, maybe that will be what I tackle after grass, my next big project. Because I'll be, well, the thing is with grass, you can keep on doing it forever because even though I have this, like, I can finally cover terrain, I could still add, like, character interaction, like growing or fire effects, more complex wind. There's, like, still a ton of things I could do to it. But yeah, I want to move on to water at some point. Anyway. Okay, I wanted to create some lights. Change it to soft shadows. Huh. Oh, it's pointed differently than I thought. Okay. I was gonna say, why doesn't it show up? Okay. Oh, I know why. It's because I haven't included any of the lighting keywords. in this shader. So what I need to do is go here, and yeah, usually we have this whole block full of lighting keywords. I can copy them from the lit shader. Okay, so this is all material stuff, so we don't need that. These are from our lighting keywords. So let's see here. Okay, so there's a lot. We got the shadows for the main light, cascades, additional lights, additional light shadows, soft shadows, screen space, ambient occlusion, subtractive light map mixing, shadow mass. This is also more shadow mass, or light maps, and then light map on and compile fog. Okay, so yeah, now with that, we finally got. Okay, still no shadows because I don't have a Shadowcaster, but we have lighting. What's the difference between displacement and tessellation? Well, tessellation just adds more vertices, where displacement would actually change the position of the vertices. Usually with tessellation, you'd want to do displacement as well. Yeah, which I am planning to do that, so we'll get into it because, like I said, can't really notice on this sphere, but you can see the silhouette here. There's like points, like it's not completely round. So with tessellation, something I'm going to look into sooner is doing silhouette smoothing, where when you turn the tessellation up, it tries to also smooth the silhouette so you don't see these points. So technically we'll be doing vertex displacement at that point. Okay, so yeah, we've got okay, additional light. So let's add some point lights. We'll just do my purple and blue colors that I've used in the foliage shaders. You understand now? Thanks for explaining. No problem, I3. Alright, so these will both be baked lights. I don't know. Okay, well, hopefully baking won't destroy my GPU while I'm streaming. That would not be good. But yeah, I guess before we do that, let's create some light probes as well. So this is baked light 01. I spelled that wrong, but and this is real-time light. Oh, well, for some reason I added a space in that time, but I'd done it before. How did you learn to do all these shader-related stuff? It seems very complicated. Just a lot of practicing and following tutorials. I always feel bad because people ask me that pretty frequently, but I don't really have a good answer. But like, I really like cat-like coding. That's probably where I got my start. And then after that, I just keep on trying stuff. I mean, I already had a very good foundation in programming because I went to school for that. So that helped, but oh yeah, light probes. Let's center it, I guess. Okay, I'm not gonna do something really complicated, but I kind of just want to see if it works well. Let's see. I need to kind of set them up so that there's different colors on each side. Okay, this should work. Do you know if it would be possible to localize the tessellation to the camera's frustum to reduce performance? That is possible in TT. I've done, well, I haven't done, but well, I guess I have done something similar. Yeah. We might look at that. There's also different strategies to try to like not tessellate triangles that are behind other triangles and things like that. What I would do, well, this is just a really quick thing because we won't get to it today, but basically you would calculate the clip space for a vertex, and then if all the clip space positions were like outside the camera view, meaning that they were well, I guess this, you can look up frustum culling to see the exact algorithm, but you can basically you test to see if all the values, the XYZ values, are between it's kind of hard to explain, so let me see here. You'll have W, and then so you take this and then you have to make sure that the XYZ values are between positive and negative W. And if that's true, then that means that all the points are inside the triangle's view. If not, then you could just set the tessellation factor to 1. So that might be one way to do it. You can do what you want in the shader graph, but there are things shader graph can't do. So I guess you can try to learn HLSL coding. Yeah, that's very true, i3. Unity is slowly adding most features to the shader graph, but I think that even when they're done, there's still going to be some things that you can't do in it just because it goes kind of against their, I guess, their philosophy. I don't know. So yeah, it's never a bad idea to learn HLSL coding. I'll put it that way. All right, so I think we're ready to bake. So again, yeah, my frame rate might drop for a bit. I'm gonna try to generate a light map. Okay, I just realized something. Well, okay, this plane might look kind of funny because technically you were supposed to turn on double-sided global illumination for it. But it turned out not to cause too much of an issue. Oh, but you know what? This shader also doesn't have a meta pass. So, but it looked like it still generated something for it, so that's good. Okay. Oh yeah, so it's getting the light probes. Yeah, you can see when it comes over this way, it turns more blue. And yeah, it's more purple on this side than it is on this one. Light probes, they're never going to be perfect because it kind of interpolates between the values. But yeah, you can see it is doing that. So let's turn off these two real quick. And let me just look at the sphere. Oops. If we move it right here, it might not be really easy to see, but I want to see. Okay, let's turn off gizmos. Okay, you can kind of see the mesh shape right here. So I wonder if I turn on or make it tessellate more, the light map or the light probe lighting will be a little bit smoother. Okay, I don't really notice. Yeah, that might actually be the normal map. I think it's going to be difficult to see because this sphere is already pretty dense. Let's, NTT. How does it interact with light maps since the geometry is dynamic? Well, basically we just take the light map position of each vertex and kind of interpolate between it. So it still works fine. You can see here, if I turn on shaded wireframe, and I can turn up the tessellation factor, yeah, and the light map, it's still fine with the ground because this purple circle is yeah, a light map. It's baked lighting, so it still works great. Oh, displacement does mess with it. So that's always a downside of using displacement in a vertex shader. In that case, probably you wouldn't ever want to do that. If it was really important to you, you wouldn't want to do it on any static object. You won't want to do vertex displacement because, yeah, the light maps won't work. But it actually is fine with light probes because they don't actually depend on the texture. They kind of just sample the light probes around it. So for light probes, you can do vertex displacement and you won't really lose anything. But now that I mentioned light probes, does it affect unlit materials? No, there's no, Unity doesn't, well, technically with the unlit shader, there's no light probe sampling, but of course you can add that in yourself, which is basically what we did in my custom lighting tutorial. What was I gonna do? Oh yeah, turn this back on. I think I'm gonna need to make something in Blender to test what I want. I want to make like a really low poly sphere and see if I can see the light probe that quality go up as I tessellate it more. We might not really be able to tell. Actually, yeah. Let's see. Okay, so the problem is right now the light probes only depend on the normal. So the normal doesn't change. Well, I guess it kind of does. Now that I think about it, this normal, I probably need to normalize it. That would maybe affect the light map. Let's see here. Because this doesn't normalize the tangent vector. So the problem is that when you interpolate normals and tangent vectors, or basically any direction vector, it's not normalized when it's done interpolating. So you kind of need to do it, but normalizing is slow. So you don't want to do it too much. So I'm trying to figure out when I need to normalize in this shader. Does it? Yeah, I don't think Unity ever normalizes. Well, maybe right here. Let's see. Hi, Sprite Creator. I feel you're the best person to ask about shaders. Material property blocks. Can you use these images in the UI class if you target the canvas renderer? I'm trying to think. I don't have a whole lot of experience with the canvas renderer, but I know that it does things a lot differently than, well, maybe not a lot differently, but it has some unique quirks. But I know well, let's see. The material property blocks don't really work in URP, but I think they should be fine in the built-in renderer. But I'm not 100% sure. As of now, you have to set everything one by one for materials. Yeah. Are you using URP or the built-in renderer? Because it's different depending on which. Oh, you're using URP. Well, on URP, yeah, I don't think material property blocks work at all because the batcher kind of handles it differently. Like it looks at all the materials that use the same shader and sets up a buffer. So you shouldn't have to use the property blocks, I'm pretty sure. So yeah, I think you should be good doing how you're doing, but it might just be that the canvas renderer doesn't really support instancing. I haven't really, yeah, I don't know. I haven't done it enough to know for sure. Okay, so this is what I was looking for. Transform object to world. Okay, so you can, oh, so it does normalize it. Okay, so yeah, it normalizes it at this point, so I guess I don't have to do it myself. Oh wait, that happens in the vertex function. Yeah, okay, so it's normalized there. So yeah, technically I think I should normalize it here. Which I guess we'll do it. For tutorials, I usually try to give correct or do like correct math, and then people, if they want to try to speed it up, they can remove certain things. So I guess we'll just do that. Yeah, sorry I can't give you more in-depth help, Bright Crater, but hopefully that will at least get you on the right track. Alright, so what am I trying to do now? Alright, so yeah, what I wanted to test with the Spherical Harmonics I actually can't do yet because we don't change normals when we tessellate, and since the Spherical Harmonics are only based on the normals, then no matter what I do, they won't actually change anything yet. So I guess we need to do that normal, the silhouette smoothing technique. Oh, well, before we do it, yeah, before we do that, let's add the other render passes. So we've got the Shadowcaster, depth, depth normals, and a meta pass. Okay, I think I'm gonna clean up my files up there. Okay, so for the Shadowcaster, we can pretty much just copy this and then, okay, call this Shadowcaster. Okay, and it's going to use the same code. Yeah, and I guess we don't really need any of this stuff because there's not any lighting on the Shadowcaster pass, so we can get rid of that, but we still have the hole and domain functions. And what I like to do is define like a special keyword for each pass. I've seen, I mean, people do this different ways. Like you can have a different file for each pass, but for me, I keep going back and forth, but I kind of like to do the, I kind of like to include everything in one file because a lot of times the passes have a lot of code in common, and it can get really difficult to try to separate them into different files. But I guess it's just kind of your style, which I can't type. Okay, so for the Shadowcaster, the main difference is that we can exit right after we clip. So basically, we just won't do anything here. So if defined forward lit pass. So if it's the forward lit pass, then we'll do all this lighting. Otherwise, we'll just return 0 after doing the clip. And then the other thing we have to do is the clip space we have to change based on the shadow biases. So if Shadowcaster pass, we'll do something else. So I basically call this helper function that I've already copied. Yeah, actually don't need this because we're not going to do double-sided rendering. So I could just call the Shadowcaster position clip space, which basically just does some fancy math based on shadow biases. Yeah. Okay, so it needs the world space position and the normal, I think. Yeah. Okay, and since we need the normal here, I need to bring this line up. If there's some kind of buffer, that's good enough. I think that should work, Sprite Creator. I know that, yeah, instead of using the property block, it does something with, yeah, like a per material batch buffer, which is kind of what these lines do. I should probably look into that more and make a tutorial maybe, but we'll see. All right, so I think that's all I have to do for the Shadowcaster. Let's see if it works. No, an invalid conditional expression. Oh, right, I just had to do if def, okay. Okay, so that works, although you can see I've got some jaggies there. I think that's... I don't have soft shadows on or cascades, so we'll fix that. Okay, that looks much better. Okay, I'll turn on anti-aliasing while I'm here. Okay. Let's see if we can finish up these passes. So we have the depth only pass, and this is for making a depth texture. It's pretty simple as well. Basically, actually I don't even have to add anything else because it just exits right here. Oh, one other thing I can do actually is we can strip out some of these attributes and stuff if we're not in the forward lit pass. Okay, so basically we only need the position if we only need all this other stuff if we're in the forward lit pass. So if def forward, oh, that's not true. For the normal, we're gonna need, oh, we'll get to that in a second, I guess. Yeah, because we'll need this normal for the depth normal pass, but let's get that. Oh, actually, wait, we'll need the normal for the Shadowcaster as well. So, and I guess we'll need the tangent because we pass it here. Okay, well, that's fine. It's not like it really... Oh, wait, and we need the UV for the alpha clipping. So I guess we just don't need the light map. So we don't change anything there. Okay. Technically, we don't need some of this stuff. I guess in the Shadowcaster, we don't need the tangent, but I think I'll just leave it because I don't think it really matters. Okay, and then let's see, if defined forward lit pass or defined depth normals pass, we'll need this, and then if defined forward lit pass, we need all this other stuff. Okay, yeah, so you kind of, it's worth it to try to strip out stuff from this interpolator struct because it saves a lot of math on the GPU because it has to interpolate all these values for every fragment. Let's actually do something. So if we'll just kind of combine these two keywords together. So now we can just use this keyword instead of that. So you don't have to type that whole thing out every time. So this would be if def. Okay. Yeah, there's no point to try to strip out anything from the buffer here because that will just break instancing, and same thing with doing a texture or sampler. Okay, so we don't change anything here. Clean this up. It's just in the tessellation or the domain function. So in the domain function, we only need to pass. So the UV gets passed always. So I guess we'll bring this up. And then if it requires, so even if we're not, so we need the normal here and the world space position. So even if we're not going to interpolate it, so let's just do this. Bring this out into its own variable. Same with the position. And I kind of want to put the position before the normal just because that's the order I'm used to. Okay. And then this would be like this. And normal world space. But so we need to do the clip space position is also always pass through. So take care of that. And I guess this has to go before. Okay, so now if we require a normal interpolator, then we'll also pass this through. And then only in the forward rendering pass or forward lit pass will we pass anything else. Okay. And then here, okay, so yeah, the only thing else I have to do is return a different color if it's the depth normals pass. Let's change this to an if def. Okay, so we have to, we gotta pack the normal into a specific color. And this is just to try to store it in the normal texture cleanly. Okay, and you can call this pack normal octrect encode. And that's in the packing HLSL in the core shader library. Core dot. Okay, so that's good. Yeah, so I didn't even really have to use the depth only keyword, but I'll just define it anyway. Okay, and now we have depth normals. Okay, so we should have everything we need. Okay, invalid subscript position world space. Oh, right. I just need to use the variables here instead of the output. Conditional expect. Okay, so that should be an if def. Okay, and this is just input dot normal, so And usually the depth normal, you might wonder why we put this here instead of after the normal map. Usually depth normals don't include normal map stuff, just to make them a little faster so they don't have to sample the normal map. But I mean, you could certainly place that under there if you wanted. Okay. Okay, and so to test this, let's add. Okay, so we know the Shadowcaster works. We can test the other passes by adding green space ambient occlusion. Okay, and then if we set it to use depth normals, and then turn on the frame debugger, and we should see that it does a depth normal prepass. And yeah, so our shader, the normals are being encoded. And if I change this to use depth, then it does a depth prepass, and we can again see our shaders, or our materials are on the depth texture. So we're good. Okay, I guess we'll just leave this on. Okay, and the only other thing is a meta pass, which I actually do put that one in a different shader because, or a different HLSL file, because it is basically completely different. The meta pass is used by the light mapper kind of to encode information about your texture or your shader if it had like emission colors or something. Yeah, and there's no culling in it. There's not even a reason to do tessellation, I don't think. Okay, let's see if I can. Okay, actually running a little late, but I guess I started late, so let's see if we can finish this real quick. Close that. Oh, this is the shadograph version. Okay, so let's make a tessellated lit meta pass. And open it up. Okay. Yeah, so it basically just takes the position, and the UV0 is the texture UV, UV1 is the light map UV, UV2 is dynamic light map UV, which I don't even know why it's in here because I don't think URP supports it. But I basically took this from Unity's meta pass, so I just left it because they asked for it here anyway. Yeah, so you take in information, and this vertex, you calculate the vertex position for the light map texture based on all this. And then you also transform the UV, and then this, you can just sample the texture for the albedo, specular color, and emission. I probably should come and update this because we're actually trying to copy the lit shader now instead of just using foliage. Like, for instance, I have metallicity, which I think would affect the specular color. Let me write a note. But anyway, it works. I don't think anything will really change, but we can try to generate another light, or yeah, light map. I guess we could see, because technically what would happen is if I added emission to the ground texture, it would start showing up on other light maps. I guess it wouldn't even affect these because they're dynamic, so they're only affected by light probes, but that's the theory behind it anyway. And yeah, I guess this is a pretty good stopping point. So I guess I'll call, oh, let's change this actually. So this should be Tessellated Lit meta pass included. But yeah, I guess we better wrap it up. Okay, so we got quite a bit done. We got the tessellation. I guess next time we'll probably work on that silhouette smoothing, and then do some other things with tessellation shaders. Like you can use them to render a height map. You can use them, like I said, to try and if you have a complicated lighting algorithm, to try to optimize that. You can use them to add like a detail bump map to textures when you zoom in real close. So we can try all that stuff. What else did I have? But yeah, the flat shading with deformations. Oh, this is different. Okay, yeah, so this, yeah, the flat shading is what I thought before. Here you can also use tessellation. Let's see, add deformation detail only where it's needed. So here, say you had like a wall, but you wanted to be able to like dynamically deform it, like if, I don't know, a bullet hits it or something, and then some of it's dented inwards, then you could somehow keep track of where that happens and then only tessellate the area where there's deforms. So that's kind of another technique. Yeah, and then we could also do this output topologies, but I don't know if we'll get to that in this tutorial. But that sounds cool. Yeah, I thought it sounds like a pretty good application of it, so we might do it if I have time. But okay, so anyway, I think that's it for today. Thanks everybody for coming by. I really appreciate it. I'm gonna try to stay on a 3 stream a week schedule. That said, unfortunately, I have a dentist appointment tomorrow during my normal stream time, so I'll be streaming on Thursday instead of Wednesday. But yeah, so I hope to see you all there. It'll be around 9 Eastern time, or not 9, 10 Eastern time on Thursday. But I'll put some links in chat if you enjoyed the stream and you want to check out any of my other social media or YouTube channel. And yeah, I guess I'll see you Thursday. I hope you all have a great night. Bye-bye.